Another topic I want to discuss for the WSA, it is going to be the decryption policies. Decryption policies is something that you may want to enable on the WSA in order to better control encrypted web communication. So this one applies to HTTPS sessions, and you might want to use this feature to not only perform the decryption of the content, which of course is generally used to perform better inspection. We know that the content, the payload of the encrypted packet cannot be inspected. With decryption enabled and performed, we're gonna end up seeing a clear text HTTP packet along with its payload, and this stuff we will then evaluate against our access policies. So decrypted flows, they are definitely inspected by access policies. This is reason number one why you would actually want to use decryption policies. With the second reason being the ability of better controlling invalid certificates. So you will be able to tell WSA what to do if a certificate of a server is revoked or maybe invalid, like it expired. You will be able to tell it if you want to block connection or maybe allow it through. And something like this you wouldn't be able to do in the access policy, because access policy is generally meant for clear text communication. Even though you can inspect HTTPS when the decryption policies are disabled, the inspection is pretty simple. You can only block encrypted traffic, like all HTTPS packets over a given port, or maybe you will block based on URLs, because the WSA is smart enough to figure out the URL from the SNI, server name indication, or server certificate, exactly like what FTD does. But other than that, the inspection of encrypted communication is very limited. Okay, so same as with access policies, we can have multiple decryption policies for different types of traffic, like traffic coming from different segments, or just traffic matching different identities, where those policies will be processed the same as access policies or identification profiles, so top-down until a match is found. The small difference is going to be in how the default action is going to be determined, which is going to be our catch-all, but we will get back to this during the demonstration. And now for the decryption to work, there is going to be one important element you have to think about. Since the decryption is performed as a man in the middle, like the decrypt resign action on FTD, you will have to upload a CA's certificate or generate a self-signed certificate so the WSA can actually spoof the server certificate to the connecting client. Because WSA is going to act as a client to the server and as a server to the client, exactly like with FTD. In terms of the decryption actions we can use in the policies, we can say we want to monitor, which is just to log, but without stopping the evaluation, without using other entries, other components of the policy. Same as with access policies. This is an intermediary action. For the decryption, you would have to choose the decrypt action. This is, of course, a final action, same as all other actions available in the decryption policies. This one tells WSA to decrypt the communication and then evaluate clear text HTTP against our access policies. We can also allow encrypted traffic or block it without doing any type of decryption. So stuff like that is normally done for exceptions, like if you have to be compliant with some policies, maybe PCI DSS, maybe HIPAA, or anything else that you know you shouldn't actually look at. Okay, now in order to use the feature to activate decryption policies, we will want to first enable what is known as HTTPS proxy. HTTPS proxy is by default disabled, And this is why decryption policies are not available for configuration. When I take a look at the Decryption Policies tab, it is going to tell us that this is not active. Right, we see it says to use those, enable the proxy. So this is what we will have to enable under security services. Okay, next we will have to generate a self-signed certificate or upload a CA certificate, in which case you will also have to make sure that the CA certificate is trusted. You will go to Network, Certificate Management, and add it to the trusted roots. So let's take a look at that. I'm gonna enable the feature. We will go to HTTPS proxy. Okay, let's enable and edit settings. And what I'm gonna use in our case is gonna be to simply generate a self-signed certificate. Okay, I have to accept the license. The same as with the regular web proxy, I can tell it what ports to inspect. We're gonna stick to 443. We will then generate a self-signed certificate. I will say that the common name is gonna be wsa.ndtrainings.com. This is for Navadyne, security, let's say Poland, and expiration, I'm gonna say 12 months. We will generate this certificate. And then we will quickly take a look at some of the decryption options and invalid certificate handling. Okay, so those options here, decrypt for authentication down to decrypt for application detection, this is where you tell WSA to do the decryption for certain applications of other features. This option here, this is what you would use, you might use if you enable authentication and you want to authenticate HTTPS transactions where the user was not authenticated previously with any of the clear text session. Because authentication is only going to work for a clear text HTTP transactions. This is what WSA can redirect. So you will have to first decrypt to authenticate. You can also do the decryption to display end-user notifications, which is what will be shown to the user when the policy blocks a transaction. Or maybe you will decrypt if you want to display user acknowledgement, which is when you tell the user that you are using a proxy and they are supposed to agree with the filtering policy in your organization. And you might also want to use this option, this one is by default disabled, to enhance the application visibility and control engine capabilities. So ABC is not able to detect all, I would say, characteristics of an application if the session is encrypted. With this option, you will say that for ABC inspection, you allow the traffic to be decrypted first to enhance the engine's capabilities. Okay, we will disable revocation checks, and then we will also change the default options for how do we handle invalid certificates. So this is talking about certificate returned by the server. I'm gonna say monitor instead of a drop. Like, what if the certificate expired or I don't recognize the root authority or just the issuer of the cert? I don't immediately want to drop. I don't immediately want to decrypt. I'm gonna say monitor, which in this case means use our decryption policy to make a final decision. And this is what we will submit. And as a side note here, note what it says. Once the proxy is enabled, HTTPS blocking will no longer be available in access policies. And also, if you had some configuration related to HTTPS in the access policies, it would disable those settings. Because from this point on, anything that is related to HTTPS is going to be handled by HTTPS proxy, by the decryption policies. Okay, so this change I'm going to push. It's just a summary of our configuration related to HTTPS proxy. Now we will save, we will push this config, and then I'm going to take a look at the decryption policy configuration. Okay, so now we should be able to add a decryption policy. As you can see, the structure of the policy is pretty straightforward. We've got URL filtering sub-engine, we've got web reputation, and we've got a default action. So the processing is going to be performed from the left to the right in this direction, like with access policies. We will first try to perform filtering, then reputation, and finally we will take the default action if we didn't have a match here or here, like if those settings were set to monitor. Okay, I'm gonna add a custom policy because I want to show you the decryption is gonna take place in our case, and I want to show you this in a controllable fashion. So we will think about which of the engines we want to use to do the decryption. Okay, I'm gonna say that this is my decryption policy. This is gonna be the name. And then we will choose the identification profile as our condition without using any other options. Same stuff as in the access policies. So just use this as a condition. The authentication is going to be disabled. Policy is going to be enabled. And we will now take a look at the config here. So URL filtering, web reputation, and then the default action. Right, same as with access policy URL filtering, you can do the decryption based on the categories or maybe individual URLs that you can add from under Web Security Manager, custom URL categories. So this is where I can tell you that, let's say, websites that are part of education, I want to allow traffic to those without decrypting the communication versus, let's do the same for finance, versus, let's say, games, I want to decrypt or maybe even drop. Hacking, I want to drop, and we will say that social networking, I'm going to leave social networking as use global settings, which is to monitor. So this config here, it's not actually going to do anything here in our case, because I won't be sending packets to websites that are part of those categories. Plus, I can also tell it how do I handle uncategorized URLs, allow without decryption, block without decryption. I don't know what to do, go to the reputation or decrypt. Okay, so we will submit. In our case, this policy is not gonna affect, it won't decrypt traffic to Facebook. Because this is what I wanna show you. We'll focus on decryption for Facebook communication. Okay, so moving on to reputation settings. This is where the decryption is set to be done based on the score, WBRS score associated with the URL with the website. You see, most of the websites will be decrypted just based on this range. It's pretty broad. I can also drop without doing the decryption if the site is really bad, or I can allow if site is really trusted. If WBRS doesn't return a score, it can also happen. I say monitor, which means that I will move to the default action, which is based by default on the global settings, and the action is set to decrypt. Again, I can change it, pass without decrypting, or I can immediately drop without doing the decryption. Right, we will not be using this portion of the policy. I'm gonna focus on WBRS. So for Facebook, once again, I said I want to monitor. We should see that the decryption is gonna be performed based on the reputation score when we test this policy. I'm just gonna commit. Okay, I'm gonna close this tab. Commit this change. And let's go to the client. And we will go to Facebook once again. Facebook, it says, is blocked, which is fine. But let's see if the decryption took place. This is CNN.com. We're waiting for Facebook. So the site is eventually to be blocked based on the access policy settings. But first thing, we want to take a look at the decryption. All right, of course, in this case, this stuff is going in clear. This is HTTP, not HTTPS. We have to change it. Okay, so HTTPS, facebook.com. Okay, the logic here is going to be slightly different now, because I'm supposed to get a certificate from the server that I will have to accept. And only when I accept the certificate and we do the decryption, we should see that the content of the packet is going to be evaluated against the access policies. Okay, so click on advanced. I'm going to say add exception. And take a look at this in the log messages. It says we do the decryption based on WBRS. Because the reputation of Facebook is 3.8, it knows that based on the URL, it's now HTTPS. So it has the reputation. Reputation is within our range for decryption. Just to make it clear, I'm going to open this once again. We will confirm the exception, and we will wait for the decryption to take place. So going back to the, and not the default action, web reputation score. Once again, the score is 3.8. And this is within this default range of minus 8.9 to plus 5.9. So we are within this range. We do the decryption. Now we go back to the client. I accepted certificate. So we should now decrypt the content, and the session is going to be blocked by our access policy, which it is here. Just to recap on the access policy, I said that they want to block all social networking websites. And if we go back to the logs, we see that decryption was performed. And then when the content was eventually decrypted, we've got the file, we've got the deny for this SSL session, port 443. This is now blocked. We have a match with our access policy. So we see that the block is in fact performed as enforced by our access policy. Now, if we were to connect to a different website, https www.cnn.com, this communication should be allowed. I don't remember what is gonna be the WBRS score for CNN. If it is something outside this range, we will change the URL component. We will enforce decryption with URL filtering. Okay, so in this case, it says we do the decryption based on the default action. We don't know what's the reputation score for this website. It says doesn't know what's the category. I'm gonna confirm. I'm gonna say add exception. Okay, we don't have anything here in the access policy to block CNN. We rely on the global settings. Just one custom entry is for social networking. So this is not gonna affect CNN.com. This is our Facebook. We take a look at news. It says use global, which is monitor. That's fine. And we see the difference. I'm able to authenticate. I am able to connect to our server, router 4, which is emulating this CNN.com website. We don't get any type of deny in this case. And notice that after decryption was done, it was, in this case, able to find the category. Right, so this step is also working as expected. In this case, we did the decryption based on the default action. Maybe let's also try to quickly change this default action in the decryption policy and see what is gonna change if we tell to block this communication. So now what I will try to accomplish is gonna be to drop the session without doing any type of decryption. Like if I know that this is the one of the URLs that I never want to access using HTTPS. Okay, I'm gonna commit. So in this case, even that our access policy says allow news, allow CNN.com, since no decryption is gonna be performed, the traffic is never gonna hit the access policy. Remember, with HTTPS proxy enabled, it's the decryption policy what is evaluated first, not the access policy, which should result in a simple block of this connection. Let me refresh. And we will look at this on the client and in the logs. We have a log message. It says decrypt admin default action. Okay, this must be a leftover from the previous session before I push the policy. This is what I wanted to show you. Drop because of the default action. We go back to the client. We see the reason for a drop is the default decryption action, and it tells us that the website is blocked because it has been determined to be a security threat to the organization. Okay, so those messages you can customize, of course. What I wanted to show you here is that we now block at the decryption policy level without using our access policy.